Number 4 asks that we find the domain of the rational function. Remember, if you're talking about a polynomial function, the domain is all real numbers. The domain stands for the x values that are part of the graph of the function or the equation of the function. So when we're talking about a fraction, there is a restriction to what you're allowed to have in a fraction, and that restriction is that your denominator is not allowed to be 0. So if I have f of x equals 4 over 9 minus x, like I do in 4a, I know that my denominator is not allowed to be 0, so that means I need to figure out what value of x would make that denominator 0. And the easiest way to do that is to take my denominator, set it equal to 0, and then solve for x. So here, if I add x over to the other side, I have 9 equals x. Well, that's not what my domain is. That's the exception to my domain. So actually, 9 is what x is not allowed to be. X can be every value except 9, because 9 would make my denominator 0. So you can write x cannot equal 9, or in interval notation, that would mean all the numbers from negative infinity to 9, with parentheses next to both of those, because there's no n to infinity and 9 is not included. And then again, from 9 to infinity. Again, the parentheses next to the 9 means the 9 is not included, so x can be all the values except 9. You can say that by saying x cannot equal 9, or by putting it in interval notation. So when I come over to b, f of x equals 3x over 5x minus 1, I have exactly the same thing. I have a value of x in the, I have an x in my denominator of my fraction. So I know that there must be a value of x that is not allowed. So I take that denominator, set it equal to 0, and then solve for x. That gives me 5x equals 1, and x equals 1 over 5. Whoops, equals 1 over 5. That's what x is not allowed to be. So again, in interval notation, that would go from negative infinity to 1 over 5, parentheses on both ends, and 1 over 5 to positive infinity. And that again indicates that x can be any number from negative infinity to positive infinity, except the number 1 over 5, because it has a parentheses next to it. Okay, for number 4c, we're still finding the domain of the rational function. This time my denominator is x squared minus 9. Again, I have a variable in the denominator, so I am going to have an exception to my domain. So I take my denominator and set it equal to 0. And now I can use the square root property, just add the 9 over, or I can factor x squared minus 9 and set each factor equal to 0. And it doesn't make any difference which one I use. So I'm going to use the square root property. That gives me x squared equals 9. Take the square root of each side. That gives me x equals plus or minus 3. So those are the things, again, that x cannot equal. If I put 3 in here, that gives me 3 squared is 9 minus 9 is 0. If I put negative 3 in here, negative 3 squared is 9 minus 9 is 0. So in interval notation, it starts at negative infinity, goes to negative 3, can't equal the negative 3, so I put a parentheses there. Then it starts at negative 3 and goes to positive 3. Again, it can't equal the negative 3 because of the parentheses. It can't equal the positive 3 because of the parentheses. And then again, it starts at 3 and goes to infinity. So the parentheses on both sets of parentheses here for the 3 and for the negative 3 indicate that those two values are not included, but everything else from negative infinity to positive infinity is included. So it can be written x cannot equal plus or minus 3, or it can be written in interval notation in this manner. For number 5a, the instructions are simplify the expression. We have a rational expression, and we're trying to factor anything that can be factored, and of course, as you can see, these are already in factored form, and then cancel any like factors. So we're trying to figure out if there are any like factors in this fraction in the numerator and denominator. Well, x minus 4 and 4 minus x, if you recall, are opposites because I have the same numbers or variables. The signs are just exactly the opposite. So what I can do with this is factor a negative 1 out of the numerator or the denominator. If I factor a negative 1 out, that simply changes the signs of what's in the parentheses, just like when you multiply a 1 in. So now this is actually negative 1 times the quantity negative x plus 4. Well, you don't have to show this step, but you can write that as 4 minus x. Take the positive thing and put it in the front. Don't need to do that, but I just want to make sure you see that these are actually now exactly the same thing. So that can cancel or divide out with the denominator that's alike. And all I'm left with is negative 1. So the expression x minus 4 over 4 minus x is equivalent, when simplified, to negative 1. Here we're continuing problem number 5, simplify the expression, which means we need to factor our numerator and denominator and then look to see if there's anything that will divide out. So when I factor the numerator, my GCF is 4. So I'm going to factor out of 4, and that leaves me x minus 3. And on my denominator, my GCF is x. When I factor that out, that also leaves me x minus 3. So now I'm looking for anything that will divide out both the numerator and denominator, or cancel out because they're alike. That's the x minus 3's, and that leaves me 4 over x as my final answer. When I come to C, if you'll notice, by magic, the problem changed. I had placed the wrong one there, so I have corrected that. So again, I have to factor the numerator and denominator. Of course, my numerator is already in factored form, so I just rewrite that, x plus 3. And on my denominator, I'm looking for what multiplies to negative 12 and adds to negative 1, which of course is negative 4 and positive 3. So that factors to x minus 4 times x plus 3. And now I look for what I can divide out of the numerator and denominator, or cancel out my like terms. That's the x plus 3 in the numerator with the x plus 3 in the denominator. Remember, when you divide or cancel out your entire numerator, you have to have a 1 placeholder, and my denominator is x minus 4. And that's in simplest form because there's nothing else alike in the numerator and denominator. For 5D, we continue simplifying the expression, and in my numerator, my greatest common factor, or what's in common, is, give you a minute to figure that out, it's x squared. So I factor out x squared, and that leaves me x plus 11. In my denominator, I don't have a GCF. There's nothing in common, so I'm looking for what multiplies to negative 88 and adds to positive 3. And remember, think down here to see if what you have here is going to be what could cancel with the bottom. So 11 does go into 88, so it means I have positive 11 and negative 8. So that becomes x plus 11 times x minus 8. And now that I have everything factored, I'm looking for factors that are alike in the numerator and denominator to divide out or cancel out. That's the x plus 11's, and I'm left with x squared over x minus 8, which is my final simplified form, because remember, this x and this x cannot be divided out because this one's not a factor. This is a factor, but down here this is a part of a polynomial, and so I can't divide it out into the x squared in the numerator. Okay, on to E. If you notice, what I have in this numerator is 4 terms. I don't have a GCF, so I'm going to try factoring by grouping. So when I look at this, and we'll pretend I'm on my scrap paper here, because remember, on your test I don't want to see your factoring in the middle of your problem. What's alike in the first two is w, and that leaves me w plus z. What's alike in the second set of terms is a 3, and that leaves me w plus z. So the factored form of that numerator is going to be what's alike here, w plus z, and what was left in front, the w plus 3. Okay, so now we're done with my scrap paper here. We're going to go down and rewrite the problem. My numerator is w plus z times w plus 3, and my denominator is w plus 3, which cancels with the w plus 3 in the numerator, and my final answer there is w plus z.